Hello out there on the internet. I'm Bret, and this is my show. Every week we're here on YouTube Live talking about GitOps and Docker and Kubernetes and all the things. But this week I'm very excited because it's one of my favorite new topics to talk about. So before we get started, just a few pieces of information about this show in case you're new here. You'll want to like and subscribe like every YouTube channel tells you to do, because when these go live, you'll get an announcement or a notification basically that says, hey, we're live, and you can come join the show, ask questions of our guests, and maybe on Q&A days, we'll troubleshoot, help you out. Today, though, we have a special guest, and I want to get straight to the show. So by the way, if you're going to wait to the newsletter, you want to sign up in that little link up there for the newsletter. That's going to let you know when our new Kubernetes course, Kubernetes Mastery, is coming out, and we'll be announcing that, sending out coupons here eventually. We don't have a launch date yet, but it's not far away. So you want to definitely get on that list. And let's get to the show. On the show today, I have Brice Fernandes out of London, I believe, from Weaveworks. Welcome to the show.
Hi, thanks, Bret. Thanks for having me on your show.
Yeah. I'm so glad you're here. I've been a big fan of Weaveworks for years, and now that they are sort of leading the pack in the GitOps movement, I'm super excited. I say that so often, super excited. Like everybody says super excited, but I am truly super excited. So let me tell you. Yeah, go ahead.
Yeah, it's a pretty exciting place to work at. So some really nice people here.
Yeah, you're actually the first guest on the show from Weaveworks, and I'm excited again. I'm super excited about talking about this stuff, because it's one of those things where you use a tool for so often, and you've used it for years, and you've just never spent a lot of time with anyone from the company, right? So you don't see the people making the product, so it's great to have you. Let me tell you all a little bit about Brice. He started working with Docker several years ago on his own startup before joining Weaveworks in London to work with Kubernetes. Right. So then he helped codify and communicate the GitOps approach, which is what we're going to be talking about today. And he helps companies make the most of Kubernetes and building production grade platforms. Brice is joining us from London, like I mentioned. And let's just start with your background and the background of Weaveworks. What's that all about?
Yeah, so I'll go through Weaveworks first, and we can talk about my background, which is a bit varied and weird. But so Weaveworks, we actually started as a company about 4 or 5 years ago. So we were about as old as Kubernetes itself. And we were trying to help people with basically cloud native computing as a company. And so we started building products. The first one we built was a network overlay called WeaveNet, which is quite popular. And then we started running our own platform, our own SaaS platform, and we were deciding, which orchestrator are we going to use? We're going to containerize all our applications. How are we going to do that? So we picked as a company, and this was before I joined, we picked Kubernetes, and the decision is kind of carried forward. And now we've learned a lot over operating Kubernetes over 4 years, since the very early days. So we've tried to codify that approach and kind of share that with everybody else. So that's kind of the path of the company. So we still have the Weave Cloud product, which is like a SaaS product, which lets you manage Kubernetes. So you plug that into your cluster, and and you have a SaaS platform. And then now we've been doing a lot of work with much larger companies to kind of help them build their own platform internally, essentially. So that's the very brief and short history of Weaveworks. I think some things to note is we're really lucky to have some of our senior team members in Weaveworks are very plugged into the cloud native ecosystem. So, for example, our founder, Alexis Richardson, was the chair for the technical oversight committee for the CNCF, and he's still on the technical oversight committee. So we've got quite a good community ties, and we do a lot of open source work in general. So we're pretty. We're very much an open source company. A lot of the stuff we do is open source, including kind of our entire data backend is now open source, is now a CNCF project. So
nice. That is a good summary. I'm most familiar with Weave Cloud and like WeaveNet and stuff like that. That was some of the original stuff. And just recently, I was poking around the site and seeing how many open source projects you have now. How many products out of that you have, and it's a lot. It's a lot. I feel like we could fill the whole show just talking about all the cool things the company is doing. But we're here on GitOps. So how did you get started with GitOps and Weaveworks? Like you personally, like what was that all about?
Yeah, so it's interesting. So I actually joined as an engineer, as a developer, and we were I joined just a few weeks before a very large conference, Kubernetes, the KubeCon, and the idea was, we needed some topics for KubeCon, and the team really didn't have a lot of spare capacity to onboard me on the engineering side. So I just said, okay, fine, I can do something about GitOps. I can start talking about that kind of stuff, and so that's really how it got started. For me personally, within Weaveworks, is kind of just doing a bunch of presentations at conferences and trying to describe what we were doing internally and share that with the outside world. So that's how I got started. But in fact, a lot of the ideas I think I'd been using myself. I just hadn't had I guess I'd never taken the step to codify them into a kind of an approach. But I'd been using, declarative configuration before, and continuous delivery of kind of infrastructure configuration. I'd been using that in my previous role in my own startup before that. So it was fairly familiar. It was just I had to codify this stuff when I started out at Weaveworks to share it with the public.
Yeah, that's true. I think a lot of us that are at least trying to be on the leading edge of this stuff, whether it's containers themselves or orchestration or the DevOps term itself, like a lot of this stuff, if you're on that leading edge, you tend to be doing it already. You just didn't have it formulated as a nice page like you have on GitOps on Weaveworks, or stuff like that, right?
Yeah, and that's the case for everything, right? Even organizational approaches, kind of the peopleware side of stuff. A lot of the time, if you kind of deliberately think about what you're doing, you'll find a bunch of new tools and techniques. But it's actually quite useful to have them come together as described by somebody. It's a nice framework, and mostly it's useful to communicate it with others. Sometimes as a practitioner, you'll know what you're doing, but it becomes difficult to communicate it with others. So what we've tried to do is make that communication step really easy around good engineering practice when it comes to operations, basically.
Yeah, I think when I first read, I'm just going to call it the manifesto, essentially, that you all put out a couple years ago, it was something that I had been working with developer teams that were getting more into the ops side, right? Mostly it wasn't the other way around. It wasn't necessarily operators trying to learn development, but the developers were getting deeper and deeper into the ops stack. And they were so used to the Git tool and things like GitHub that we were trying to use a lot of what I would consider maybe pre-container or legacy tools at this point, and trying to use them in a way that we could codify them, describe them in YAML or some other configuration file, and then version that. But it was increasingly challenging to make all that automated in a reliable way that now, like all these GitOps tools are doing. You didn't. The way that every one of those tools had a different command line structure, and it wasn't necessarily ephemeral is the wrong word, but it wasn't. Can't think of the right word. It didn't describe it in a way so that you could reliably implement something and then back out, right? You couldn't go to old versions.
Yeah.
There was no way to get back from where you were. And so using the Git log process of like describing your history wasn't always reliable. And it was hard. I mean, there was times where we were banging our head against the wall with AWS trying to, implement something and then realize that it wasn't working well, and undo that change was always the hardest part in infrastructure, unlike code developers that could just revert to an old commit.
Yeah, and I think there's still some fundamental problems here around data, right? Like stepping back data schemas is still an open problem that hasn't been figured out. There are some people doing some really good work around it, but it's still genuinely difficult. I think there's like a fundamental problem, and it used to be that we had some incidental complexity around kind of rolling back changes that didn't need to be there. So what we're trying to do is get rid of that incidental complexity, and we can actually concentrate on the things that really are difficult to do fundamentally, and not just because we have bad tools, which is kind of that's the issue. You end up, once you've solved those infrastructure rollback problems, then you start talking about data rollbacks and schema rollbacks, and that's the next step up, and much more complicated. Right. So we want to get to those meaty problems as fast as we can, basically.
Yeah, and I think that the more normal, I mean, Kelsey Hightower, I think, had a tweet one time he talked about that eventually DevOps won't be a thing. And I think some people misunderstood that as in like we're going to replace it with something. And I think what he was really talking more about was that it will be embedded. Our mindset will be such that it's embedded in everything we do. The tools we use, the monitoring tools, our mindset, everything we do, we automatically assume those approaches and those workflows. And I really feel like GitOps is that next evolution of the tools eventually that survive this evolution will all have this mindset of I need to roll back. I need to be able to iterate each change discreetly and understand the nuances of how to undo changing of infrastructure, right? Because a lot of times we're permanently, the history of tech is that we permanently change things when we touch them. And we don't really have that consistent across the board, like you're saying. So this is a great conversation. And for those of you this is the first time you're hearing about GitOps, maybe we should back up a second and give you like the 101 sort of elevator pitch of GitOps. Do you want to throw that out there?
Yeah, absolutely. So GitOps is a bunch of things. You can think about it in a bunch of ways. So really, it's an operational approach. It's how you operate on your infrastructure. And it's derived from practical hands-on knowledge and prior art. So there's been a lot of work being done in the infrastructure as code space, and so we're reusing that shamelessly, right? Because this is good work. And so what we've added with GitOps are some ideas around how do you do control loops for your infrastructure, not just an one-step application, but actually have a control loop, and how do you enable rollbacks, history, auditing, etc. And so really, like the core value is you can do operations faster. That is the core value to your company, right? If we talk to a CEO, why do you care about GitOps? You can change your infrastructure faster and safely, right? You can increase the speed of change while reducing the number of defects. And we've seen that in practice with some of the customers we've been working with, right? We've seen, because you can measure that kind of stuff, like the number of commits on your infrastructure, number of changes per week. And so you see changes going up, like the rate of change going up, while the rate of defect and downtime going down, because you've got better safety and security tools, essentially. So that's the kind of high value, the high level pitch, is you can go faster safely. Which makes a big difference in infrastructure.
Yeah, and we've had this conversation before about GitOps and what is GitOps, and it's funny because it's a little bit like DevOps in that people. It does involve tools, but it's more about process and workflow and people than it is about the tools that do it, right? And DevOps, I think, is very much confused about the same way, where we think that every tool claims they're DevOps. I have the word DevOps in my title, which shouldn't be there, right? It's not. It's not a job.
It's same as Agile, right? Agile had the same problem, right? It's like the practices versus principles, and so I think what we're seeing is we see a lot of people talk about practices rather than talk about principles. But really, Agile, DevOps, GitOps, those are about the principles. It's about the why and not necessarily the how. And so really, GitOps has the word Git in it, which is a bit unfortunate, but it's not really about Git. Git just happens to be a really good tool to implement those ideas. Yeah. And it's a nice marketing term, right? GitOps. It's a nice marketing term that people can remember. But I think it's moving towards the principle approach is quite important.
Yeah, and of course, once you're thoroughly invested in the principles and you've got those down, obviously tools is going to be one of the next things you focus on, and can possibly for some people be the harder part. Honestly, though, I find that the longer we try to implement DevOps and other things like this, the more I find it that tools isn't the hard part. It's the principles part, right? It's the things that people forgot. So there's a couple of things, and I love that you have set up principles of DevOps, and it's not quite a checklist, but it's getting pretty close to how to really determine if you are doing GitOps, right? Because we kind of have that problem with DevOps, like I stated. And we had a previous conversation here with some of the team from CloudBees, and we were talking about that just because you're putting YAML files in Git doesn't mean you're doing GitOps, right?
No, absolutely.
Yeah, and they set up some pretty things of this like if you're doing this, you're not doing GitOps. If you're doing this, so why don't we go through them one by one because it's a great list. The first one on the list there is the entire system is described declaratively.
Yeah, so this is really interesting, right? Because we've heard people. This is kind of from the infrastructure as code side of things. So we've heard people in the past say, "Well, we do infrastructure as code," and when we actually ask them, please show us your repository, show us what you mean. What they actually mean is they have a bunch of scripts. That is not infrastructure as code. That's the big step, right? What we're really talking about here is data. We want infrastructure as data, and that idea is not a new one. It's really old. So Microsoft has had the model-driven data center, I think it was called at the time. So that's an old idea, but it's a big difference. So it's a set of data that describes your infrastructure. And the reason why that matters is it's much easier to manipulate and validate data than it is to validate code. If you want to validate code, you essentially have to solve the halting problem, right? That's the problem you're facing with. You have fundamental computational difficulties in validating code correctness, which you do not have for data. So if you have a data structure, it's very easy to validate for correctness in a way that a set of scripts is not. So we want the entire system to be described declaratively. And when we say the entire system, we mean the entire system. We don't want any bits of our infrastructure to not be described, because as soon as it's not described, you don't really get an understanding of what the system should look like, what your intent for the system is. So that's really important. It's actually encoding human intent in a declaration. So that you can kind of start manipulating it, and just declaring human intent in a declaration alone is already quite useful. So that's kind of the first principle.
Yeah, I like that. And of course, it's one of these things where you've got to start somewhere. And one of the things that I talk about a lot when I talk at conferences is around the idea of a lot of these things, whether it was 12-factor or Agile or DevOps or whatever. These things it's a process, and obviously you can't go from no infrastructure as data, like you're saying, and go from that to 0 to 60, right? You can't suddenly have everything deployed as immutable infrastructure. And I tend to lean teams towards starting at things that change the most, right? So like automating your deployments is something that I actually prefer. If they've already got the infrastructure out there, and they're already doing work, and they're now trying to get this more in a declarative format, right? I always focus on the apps because I feel like we're usually not deploying infrastructure every day, hopefully, unless you're like dynamically scaling. And then if you're doing that, you're probably already infrastructure as code. But yeah, this is when we're talking about these, it's like sort of a stand on my soapbox moment of saying, there's a beginning and an end, and the end is probably you're never going to be there. Like you're never going to be perfect. You're never going to have everything being able to roll back without any side effects or any weird things happen. So yeah, cool. I like that. I like the entire system. So all right. So the next one you have up here is
yeah. I mean, for the entire system as well, I think. You're going to be dependent on third parties, so you can't guarantee that there's a declarative way of configuring your system at all. So a Cisco switch is configured by logging in and typing some command at a terminal. That is how you configure it, and there's no declarative API to do this. So you can write a declarative shell on top, but it's hard, and
right.
the cost benefit here sometimes doesn't work. Sometimes it's okay to not be there, but.
Yeah, and that's true. That's what I feel about a lot of the. They're not really legacy tools, but it's the configuration, the server configuration tools as well that we've had for decades now. The Puppet, the Chef, the Ansible, the Salt Stack. Like these are essentially, to me, wrappers on top of a system that is designed to, like, anything you do is a permanent change that can't be undone. And these tools try to wrap some sort of declarative approach over top of it, but it's never perfect, right? You can never uninstall Python to guarantee that there's not even a single file there that wasn't there before, right? Yeah, it's tough.
Yeah.
All right, number 2, I like it. Number 2 is the canonical desired system state versioned in Git.
So that's kind of an awkward way of phrasing it, but it captures everything you want in there.
Yeah.
So canonical is the idea that you have a single place, like it's a dry principle, right? Don't repeat yourself. So don't repeat yourself when you're coding means don't have two sources of truth for the same piece of data, essentially, or the same idea. And so the canonical desired system state. So desired means that it's your intent. You're encoding your intent in a single place, and you're versioning it in Git. So this is quite important. The versioning gives you a lot, right? If you have versioning and you have declarative state, essentially every change is a transaction that can be rolled back really easily. So already, we've not gone into some of the later items in the list, but you already get a lot of value by just implementing those two things. So this is why kind of having everything in Git is a quite good idea. And I've found that Git is a really good place for humans and software to work together. So on the internet, nobody knows whether you're a dog or not, right? That's the idea. And it's the same way with machines. Nobody knows whether the agent making a commit is a human or a piece of software. So it's a good place for human and software to collaborate.
Interesting point. As the AIs take over, it's going to be less and less humans doing that work. Yeah, and as an operator, like someone who's got that sysadmin background, I still today am teaching people that are running data centers about Git, right? And having them create their GitHub account for the first time. And so for me, I really appreciate the idea that Git is this place for it, because it's the one place that I feel like on the internet we've actually figured out it's the best way so far that we can get operators to collaborate with developers on the stuff we're deploying, right? And it's not a tool. It started out as a tool simply for software code, and has now journalists use it. Web editors use it that are just making text on a website. Like so much other utilities have been wrapped around Git, and I feel like this is that perfect place for us to take the operators who aren't traditionally working heavily with developers and take the tool and use the best parts of it, so that, like you said, like the Git log is truly showing the history of infrastructure. If I can show someone that and say, look, you can actually, you're an executive and you don't know all these tools, you don't have Git installed on your computer, but I can give you read access to the Git repo so that you can look at our change history and change rate on infrastructure. There's not a lot out there that will do that, right? If you, before this situation, you would have to be an engineer, but giving a mid-level manager access to see this, it makes them feel special, and two, it makes it look like your infrastructure isn't a mystery. It isn't like, oh, we got to go talk to that person over there to know whether or not the servers changed yesterday, which is the de facto standard in most organizations. Is there's one or two people that know whether or not infrastructure changed, and the way that they find out how it changed isn't always obvious either, right? They're diving into logs and pulling stuff out, and so this immediately gives us a super clear view of what that's doing, what the change rate is. So.
Yeah, transparency makes so much difference. So we implement all this stuff internally. So we have a really transparent process for managing both our cloud infrastructure, but also our IT infrastructure. So like permissions, etc., which means that basically it's all self-service, right? You can trigger everything self-service. You can see exactly what you're doing. And then the set of people who actually have write access is quite limited, but because it's so permissive on read and suggestions, it means the rate of change can be quite high. So we're no longer bottlenecking on key individuals, which is a big deal. And Git is actually a very kind of the tool itself. I'm not going to talk about the tool itself, but the model of how Git deals with change is excellent. It's a really, really strong model of how you think about change sets, etc. And I mean, I quite dislike talking about blockchains in general. I think that's kind of a super hyped term that doesn't help. Right. But the ideas of having a Merkle tree as to do versioning is a really good idea, right? It's a fundamentally good idea that has very, very strong properties on assuring that changes can't be made without people knowing about them. So kind of I really like the technology underlying it. The ideas underlying it are very strong.
Yeah, it's funny you're mentioning blockchain, because the ledger. I just have to say ledger because that I actually had someone recently come to me and they said they follow someone about blockchain. They're not even in tech, and they just follow this particular person that talks about Bitcoin and blockchain stuff. And he asked me, "What is the ledger?" And and what's funny is that's exactly what the Git log is. It's this sort of this thing that cannot be undone once it's done and distributed across a bunch of people. Not quite the same as sort of the guarantees of a blockchain ledger. But anyway, I just had to throw the keyword term in there so that the robots on the internet would then suddenly pick up this show. We'd get more hits because we said blockchain and ledger.
That's fine.
Yeah. So one of the things about that's kind of implied, I feel like, with this number 2 here is that the operators that are used to shelling into servers and running, kube control commands or Docker commands, to me, the number 2 implies that you're no longer doing that, and you probably shouldn't even have access to a lot of people having that kind of access to do that. You're now doing Git commits as the way you change rather than SSHing in. And that was one of the "you're doing it" wrongs from one of our previous YouTube videos here, was if you're shelling into a server and typing tool commands, you're doing it wrong, right?
Absolutely right. So that is one thing that's. I mean, we literally have a slide that shows exactly this, right? It used to be that your operator, your person, would have direct access to your systems. We literally put a big cancel sign on that arrow and just change it to like your operator now has access to a repository, and then the repository changes are driven into your infrastructure through some agent. And this is really important because actually, auditing direct access changes is a certifiable nightmare, right? If you want to audit how people change your infrastructure and you let them shell into it, it's just so painful. To have a kind of coherent understanding of your infrastructure at any point in time becomes very, very difficult. So by moving that out and putting that in Git, you have a really strong single point where you can actually apply things like auditing. Like, what's happening to my infrastructure? Well, it's all in the Git log. And the Git log will tell you everything you need for an audit, which is who made what change, when, and why, right? Those are like the 4 things you really care about. And all of that is recorded.
Yeah.
So absolutely. Yeah.
Yeah, great. We're on to number 3, and that is kind of basically the end tail of the conversation we just had, which is approved changes can be automatically applied to the system.
Yeah, so now you have this Git repository and you can make changes to it. You're going to have some agent that's going to be running somewhere that's going to be listening to changes and reacting to changes in that repository and applying them to your infrastructure automatically. And we talk about approved changes because you want to have a gateway here. That doesn't mean that any change can be accepted and automatically applied. And so the idea is that this agent is running in. Right now, we're talking about the agent in one direction, right? It's taking changes from your Git repository and applying them to your system. And what's really interesting here, because we split up what the changes are and how they're implemented into 2 separate concerns, right? What the changes are, that's declarative, that's in Git, how they're implemented, that's done in the agent. It means that the agent with the credentials can be moved into your security zone. So it can be moved into your kind of secure area on your system. So previously, you might use CIOps, what we call internally CIOps. CIOps means that you have credentials in your CI pipeline that then go and poke your production system to deploy a new version. That's an anti-pattern, right? If your CI toolchain has direct access to your production cluster, the CI toolchain is a very large attack surface area. Not only is it a large surface area for attacks, but it's basically designed explicitly for remote code execution, right? It's kind of like the worst environment you could imagine in terms of security. So by splitting those 2 things into 2 separate concerns, you're moving the deployment agent inside your security zone, and then it's just listening to something outside of the zone. But it's a one-way, it's a read access, right? So you're reading the changes, you're applying some verification to make sure that the changes that you're seeing are valid. And one way of doing that is, for example, signing Git commits, right? So we have that infrastructure in place already. There's a public key infrastructure in place for that kind of stuff. That's the tooling already supports it. And then once those changes are noticed by the agent, they're applied to your system. And this is where you get the speed up, right? This is where you get the speed.
Yeah, and that's using tools like Flux, right?
That's right.
Yeah.
Yeah. So Flux does this exact thing, right? Flux is the deployment agent you would use in this case, specifically for Kubernetes.
Yeah, and let's just check that out real quick while we're sitting here talking about this particular thing. So this is Flux is correct me if I'm wrong, but Flux is an open source tool that Weaveworks started. That's now a CNCF sandbox project, which basically means that it's getting wider industry support and adoption, right?
Yeah, that's right, and it also means that the governance of the project is now owned by an open source community and no longer by Weaveworks. I mean, we're obviously still develop it, still very influential. A lot of the people who work on Flux are Weaveworks employees, but fundamentally, it means that the community now owns Flux and owns the future of Flux, and that's quite an exciting development.
Yeah, the features of it are, when I first looked at it, back when it was announced, I don't remember when that was, last year. I'm not sure if it was this year or last year. But I was mostly focused on how it connected to Kubernetes and just made the changes. But it sounds like it's getting more and more features. What's some of the stuff that it does now that maybe it didn't do on release or something? Do you remember any of that stuff?
Yeah, so I think the validation is one of them. We've also developed some hooks so that you can do pre and post, essentially application hooks to do things like on cluster validation. We're working quite closely with the Flagger and Argo CD teams. So these are two other open source projects to try and build a coherent picture around GitOps deployment and GitOps pipelines. So right now we're doing some very interesting work with those two teams. So Flagger is a project by another Weaveworks employee, Stefan Prodan, who put together Flagger, and Flagger is a progressive delivery tool. So it uses GitOps to do things like canary releases or blue-green deployments. And then Argo CD has some really strong pipelining tools. And so expect some announcement in the next few weeks about those three projects, and expect close collaboration in the future to kind of drive a more coherent experience that isn't just about moving manifests into Kubernetes, but has a kind of a broader context on operations, pipelines, etc.
Yeah. And I think you said this already. It comes in as a GitHub operator. Is that right? I'm sorry, a Kubernetes operator?
Yeah, so Flux, what we'll do is Flux will sit in your Kubernetes cluster. It will listen to your Git repository changes, and it will listen to your image registry changes. So if you have a new Docker image, for example, and then you can configure it to, obviously, anytime the repository change, anytime the Git control or configuration repository changes, those changes will be applied to the cluster. But it's also smart enough to do things like automated deployments if you give it a certain policy. So for example, you could tell Flux to look at the image registry, and whenever there's a new image that has a semantic version tag that comes up in your registry, Flux could automatically deploy that into your cluster. Now, obviously, because we're doing GitOps, Flux won't just deploy it and not record that somewhere. What it will actually do is it'll create a Git commit back into your configuration repository. And this is the human software collaboration I was talking about earlier.
Yeah, it was my leading question. That was my question that was going to be next. Is like, how do I know that happened?
Yeah, exactly. So Flux will make a commit and say, hey, I'm Flux. You told me that every time there's a new image that matches this pattern, I should deploy it. So I'm making a commit to that effect. And now I'm going to apply that commit to my infrastructure.
Yeah.
And it's the scope of this is broad, right? Because Flux is essentially deploying Kubernetes objects. If it's a valid Kubernetes object, it can be deployed, which means that it opens up the door to doing GitOps with CRDs, so that you have providers and you have that control loop of, let's say, an infrastructure provider or a DNS provider. Well, you can now do GitOps for your external DNS, which is quite exciting, really.
Interesting.
So that's a positive feature of using Flux in that way, is that it'll work for other objects, not just the standard Kubernetes object, but any object.
Yeah.
Including, and this is some of the stuff we're working on actively right now, including things like the cluster API, so like machines and clusters, which means you can start doing definition of clusters through GitOps. You'll be able to provision clusters through GitOps. Once you have an initial kind of a bootstrap cluster set up, you can start doing more things with GitOps by setting up new and other clusters. Which is something that we're actively working on at the moment.
Yeah. Yeah. So those of you that have ever built a Kubernetes cluster, there's now a formal API getting built around that, and I believe kubeadmin runs against that API. I think. So if you're using kubeadmin to build your clusters, then you're already doing this. You're just using a human tool. So a lot of us, if we wanted to automate in the past, here's a great example, right? You just mentioned the cluster API. In the past, what I would have done was I would have got something like Ansible or Puppet, and I would have built some of the YAML for that tool around running kubeadmin commands. And then that tool would have run kubeadmin commands for me, which kubeadmin is designed for humans to run largely. That would then talk to the cluster API possibly, or use that API rather, to build out clusters. It's not like that API is running somewhere. But what we're doing, the difference here is that, and it's a subtle difference because I'm thinking, well, okay, so we're not necessarily needing the other infrastructure tool at this point, and it's all done in the cluster. So you technically, I guess, have to have a Kubernetes cluster to start with, because there's got to be something.
Yeah,
Chicken
I
or
say
egg?
this a lot in my training, right? It's like it cannot be turtles all the way down. So there's got to be a layer somewhere where you provision something that's not GitOps, right?
Yeah.
There's going to be a fun somebody's going to run some command somewhere and provision something manually, or at least it's going to be imperative rather than declarative somewhere. But everything else on top of that is going to be declarative. So yes, there's going to be a layer where you have to provision this yourself. But the experience that we want to create really is, you want a new cluster or you want a new virtual machine. What you do is you define it in a YAML file or some other configuration file, and then you commit that to Git. Right, that triggers everything else you need to do, and you want to remove the machine. You want to deprovision a new machine. Well, then you just remove the file and make the commit, and that will do exactly what you intended to do. That's the experience we're trying to drive towards. And right now, it's not complete. It's hard to create a complete experience around this. There are still some bits missing for the entire picture, but we're getting very close in certain platforms to get that kind of working exactly the way we want it. So we've got that working on things like bare metal, right? If you want to do that on bare metal, then we've got that working on bare metal. We've got that working on AWS with EKS, for example, and we're trying to broaden that approach to many other platforms.
Yeah, and the file names, I mean, like the file types that are supported here. That was actually a question from chat. Is what is it reading from your repo? Is it reading Helm values, Terraform files? Like, I'm guessing at some point there's a I guess a list of CRDs. I'm trying to think. Is it just supported file types?
Anything that is a valid Kubernetes object. So Flux is very Kubernetes centric. GitOps itself isn't about Kubernetes, although it's a really good implementation of it. But it's so GitOps is kind of a much broader concept, and we can talk about that later. But Flux, anything that's a valid Kubernetes object can be driven and installed and deployed through Flux. Namespaces, services, CRDs, CRD definitions, roles, role bindings, persistent volume claims, persistent volume definitions, all of that stuff. So you want a new volume on your cluster. You want to provision like an Elastic Block Store, AWS Elastic Block Store volume. You create a piece of YAML, you commit it. Flux brings it into your cluster. The local operator picks that up and then provisions the volume in AWS. And for you, the experience as a user is really good, right? Because you can use templating very extensively. You were talking about data. We're no longer talking about code. So it means that templating becomes trivial. So you can build very powerful templates that really empower and enable the developers and the operators to kind of do lots of things very quickly in a very clean way. So this is quite nice.
Yeah. So when you say templating, are you talking about like Customize or Helm?
So it's pretty much template system agnostic.
Okay.
So for example, for Helm, we support Helm through this process too, right? So for Helm, what you'd do is you'd have a value file, and then you'd have a small CRD that would point to the values and that would point to the chart declaratively. So you'd have your CRD pointing, your tiny CRD is like 5-6 lines of YAML. That would point to the chart, that would point to the values, and then that would be a declaration of what you want installed on your cluster. And then that would be the object that's sent to Kubernetes. And then the operator in Kubernetes would take that, grab the chart, and then apply it on the cluster.
Makes sense. And then the last part of this is number 4, software agents to ensure correctness and alert on divergence. So that rogue,
this is basically
me being that rogue admin logging in and changing the system. That's me.
Yeah, I like to call those pepcac errors. I don't know whether you've heard the term before, but a problem exists between keyboard and chair. So these are operator errors, right?
Yeah.
So this is really nice at kind of solving operator errors. And I like to think of this as closing the loop, right? So far what we've been describing with 1, 2, and 3 is a one-directional process. And this closes the loop. This is continuous monitoring. And this is very different to what we're kind of used to. This is where most of the difference actually comes in. It's no longer a case of that you trigger a job that then modifies your infrastructure. What you're actually doing is you have an agent that is continuously running and applying the correct configuration on your system. So you have a very, very tight loop. And that loop is less than a minute long, right? So if something goes wrong with your infrastructure, and for example, you lose a machine and you declare, I should have 7 machines, and the agent notices, well, there's only 6 machines here. The agent within a minute will start creating a new machine for you in your virtual, in say AWS, GCP or Azure, whatever it is, even on premise, if you have something like, or on bare metal, that can still trigger a provisioning step. So this is kind of having that tight control loop matters a lot, and that brings out an enormous amount of difference. And if the agent is capable of bringing, this is drift correction, right? When your system drifts away from its configuration, if the agent is capable of bringing the system back from drift back into kind of the golden path, then it will do so immediately. And if it is not capable of doing so, then it will alert a human. So humans get very quick feedback on what's going on with the system. Whereas before you'd have to wait until an alert triggers by kind of a service alert, a service disruption. Here the alert will come and say, my system no longer matches my intentions, and me as a software, Flux can't remedy the situation. We can't fix it automatically. And that's a really useful thing to know as an operator, because as soon as that happens, that means your system is no longer meeting your intentions, and you want to know then, not when something else burns down later on. And to kind of bring it all together, this might be, I like to think of this as React for infrastructure. So if you've done front-end development, this model is actually really familiar to you with React. React has a data source that you use, and then it has a view, and you declare how the view is derived from the data source. And essentially, as soon as you change the data source, the view automatically updates. It's exactly the same thing here. This is React for your infrastructure, right? This declarative model where you have data that then gets transcribed into a view. Well, the view in our case is a bunch of physical infrastructure, but it's the same model. Data automatically derived into a set of views, and then when that data changes, the views get automatically updated.
Yeah. One of the questions from earlier was, well, actually, let me skip to this one, just because this is exactly what we're talking about. Let me bring this one up. The question on what if Flux agent is down, will it heal itself?
That's a really good question, actually, and the answer is no. Like as I said earlier, right? There's going to be a bottom layer where that's going to trigger. The bottom layer is going to be imperatively created. So in our case, for Flux, if you deploy open source Flux, then Flux is your bottom layer, right? So you have to install the Flux, and if that goes down, then it won't heal itself. What you can do is set up alerting for that to notice that on Kubernetes. So Kubernetes, if you set up Prometheus, I'll just mention Prometheus alerts, right?
Yeah,
this is really common. You can set up a Prometheus alert so that as soon as that happens, as soon as your Flux deployment goes down, you'll get a critical alert and say, I'm no longer in control of my system. In Weave Cloud, what we've done is we have a kind of a beachhead agent that does actually monitor Flux and brings it back if it changes, which causes no end of confusion, because people go and kind of manually modify the configuration for this stuff, and then within a few minutes the configuration's back to the old one, and they're quite confused. That's the GitOps loop in action, right? That is by design, not by default. But yeah, so fundamentally, there's going to be a layer where you need to monitor that in a traditional way.
Right. And another question similar to that was, is Flux running in its own pod on the cluster?
Yes, is the answer. Absolutely. Flux is running it as its own service, as its own pod on the cluster. We actually deploy Memcache alongside Flux just to make operations a little bit easier and to reduce the load on various APIs. So yeah, it's a pod. It's a collection. It's just a pod on the cluster, and you could run it as a. I think it's yes is the answer.
Yeah, and it's interesting. There's a question here that is where is Weaveflux better than Argo, and it leads me to a slightly different discussion around that. There are traditionally we have had tools that are CI, and to me, a lot of CI tools, continuous integration tools, are really they're automation engines. You write in their language, and then it will do a bunch of things that you need it to do, and then give you reports and status and all that stuff. And over the years, we have started to take CI solutions and use them for building infrastructure and then doing the CD part, the CI/CD part of continuous deployment or continuous delivery or whatever you want to put on the end there. And what's interesting is I feel like with Flux and a few of these really new tools that are more focused on the Kubernetes specifically, they're separating out, and tell me if I'm wrong here, they're separating out the CI/CD again, and they're making the CD part a discrete automated action so that your CI can then go back to just being the CI tool that it was probably designed to do, right?
Yeah, I'm so glad we're having this discussion, right? I keep saying this myself. We've ended up using a bunch of build tools, essentially tools that are designed to build artifacts. Building immutable artifacts is the core of CI. And we've been using those building tools to automate infrastructure, and there's a massive friction. If you've ever tried to do infrastructure automation in Jenkins, you know exactly what pain I'm talking about here. It's like those tools are designed for different purposes. So trying to separate those concerns of here's a tool that builds immutable images, immutable artifacts, software artifacts, and then here's a tool that actually takes those artifacts and then applies them to an infrastructure. Those are completely separate concerns. The usability requirements are very different, right? You're going to be using a different interface to do both of those tasks. So that's one thing I really like, is that we are now separating those concerns back out again into different tools. I think you get, it's slightly more complex in one way and a lot less complex in another, in that you have to learn another tool. But the good thing is that tool is designed specifically for that task. It's kind of applying the Unix philosophy to your pipelines.
Yeah. And I'm not an Argo expert, by the way, but I think that it does both CI and CD, and I think it's a relatively new tool compared to something like Jenkins. So it'll be interesting to see how the new evolution of these CI/CD tools that were built from the ground up with containers and specifically Kubernetes in mind, and are trying to solve the problem that traditional tools like Jenkins was solving, or Circle CI or whatever, and they're doing it without all of the history of this used to be largely a building tool and testing tool. And so it's not like it's impossible to combine these tools together, but like you're saying, I've been on very large infrastructure projects where eventually the automation team and the build engineering team, like the infrastructure automation team, is not the same as the build engineer team for the developers, right? And they both want to use Jenkins, and it inevitably turns into two separate Jenkins deployments because the trying to get that one tool to have the permissions and the security and making sure that the workflows are all isolated so that the people managing servers don't let the developers writing code that want to test a new thing change how their servers deploy, right? So it's a more traditional, isolated, non-DevOpsy approach, but it is a challenge, and not every organization can achieve the goals they want when these tools are so deeply integrated, right? So it's nice to have an option.
Yeah, and I think to go back to the original question around like where Flux is better than Argo, Flux and Argo are very similar projects. Argo has a bigger remit around the automation in general, but it is still, I think, it's still pretty deliberately in the automation space and not in the build space, which is good.
Okay.
And we, as I mentioned earlier, like expect much closer collaboration between the Flux team and the Argo team in the future. We're trying to work together really, and I think this is one of the few cases where we're seeing open source projects converging rather than diverging. They're not forking; they're kind of conglomerating, and that is a good thing, right? That is a good thing to have that effort all point in one direction. Because it'll be better for the community, right? Because the tools, the responsibilities of Argo and Flux overlap. They're not the same exactly, but they do overlap. And so we should be seeing some really exciting things, which I can hint at, but I can't actually say until we finish KubeCon. So expect announcement in the next few weeks about this stuff.
KubeCon is such a center of gravity for all this stuff that this isn't the first podcast we've had this autumn, rather, that people have said, so we'll talk to you near the end of the year about some new stuff. I'm like, exactly. I wonder what thing happens near the end of the year. So I had another question. And, what's there's a new organization partnership around CI and CD. I know CloudBees was announcing it. Can you remember can't remember what I'm talking about. It's like, it was basically.
Sorry, Bret, not sure.
Yeah, it was marketed as a sort of like a sub work group of the CNCF, but I'm not sure if it's tied directly to CNCF. That was around CI companies coming together on cloud native infrastructure and trying to agree on a lot of these things like file formats and whatever API standards or something. And I cannot think of.
Yeah, I believe there's a special interest group for pipelines. So I think that's in the work. I think it's going to take a while for that to come out and be kind of usable and be kind of useful out of beta, But I think there is a special interest group within the Kubernetes space for cloud native pipeline definitions, so that we have a common format for pipelines, and that would include CI and that would include CD and automation in general.
Right.
And what's really exciting is they're already thinking about declarative pipelines.
Yeah, and I've said this several times on the podcast since DockerCon in June or May. No, maybe April, May was right around DockerCon, and I had a live show from DockerCon, right? And one of the discussions that kept coming up on the sidelines, and we just talked about it in the show, was that containers is approaching a solved problem. We've got all these different standards now with the OCI and whatnot, and now orchestration is starting to figure a little bit of that out, even though there's a lot of commonalities with things between like Kubernetes and Swarm, but I think they're tending to get more diverged at this point, or Kubernetes is just taken off and everything else is sort of staying where it's at. And there was a lot of conversation around that. The CI/CD world is the next big opportunity. So we were seeing new funded startups in Silicon Valley around automation and CI, and we're seeing all these little container-focused startups that are related to security automation and stuff like this, right? This kind of exact thing. And so there was a discussion for like 20 minutes around how, what are we going to see in this space that's going to, what inventions will there be in 3 years that we're going, we got to all have this now. And I feel like we're getting pretty close to it, like with this GitOps stuff.
It's really interesting, the parallel between that and physical containerization, right? Like physically containerizing goods enabled a whole bunch of workflows that just could not be done before. And I think what we're seeing is kind of the same process in the digital space. Like with containerizing stuff, that's actually it's already enabled a bunch of things that couldn't be possible before. And we're still seeing, we still haven't finished, that wave hasn't kind of passed completely yet. We're still seeing a bunch of stuff. And I think that's what the CI/CD opportunities, I think that's what you're talking about.
Yeah, definitely And the idea that you had earlier that's really sticking with me is the idea that I'm putting this tool in my cluster that's going to make Git commits to the repo that I created in order to automate the cluster. Like that inception layer of automation there is actually really interesting. And I think because we keep hearing these marketing terms, and you see it in certain news outlets about the automation of the AI in infrastructure. This is like a thing that I keep reading about. And of course, everyone has to throw the word AI in everything because that makes it suddenly more interesting.
Doubles your VC funding, right?
Yeah, that's right. That's right. You got to get, in order to get your funding, you've got to have AI on the front page. And I never really, I keep reading about it, and I still don't really, I haven't seen it. So I'm not really on board with that idea yet. But I feel like this is one tiny little, toe in the water of what we're talking about here, is that this isn't AI. This is just automation.
No.
But that eventually there will be enough intelligence where, the auto rollbacks maybe is already a feature where if you're having deployments that are starting to have, that your health checks are failing, your liveness checks are failing or whatever, that this automation is just going to simply revert to the last. It's basically going to do a git commit where it reverts back, and that will then lead it down the road of rolling back, even though we've got these features in Kubernetes of rollback, that itself doesn't necessarily feed back into your Git repo. So there's discussions where some of us, when we have too many beers and we're discussing what is truly declarative, talking about things like rollbacks that's technically not declarative because it's the end state is not what I committed to code or committed to the repo, stuff like that. So it's interesting where this is all going.
So it's really interesting you mentioned that. So Flagger does that exact thing.
Oh, okay.
Right, with Canary releases.
I figured somebody's already doing
does that. Yeah. So Flagger has already started to do that exact thing. It's not intelligent in that way. It's very well. It's not. There's no machine learning or AI in it. But what it does do is it'll actually take a Canary release, check that the actual new version is meeting all the requirements you've defined, and if it does, it'll roll it out, and if it doesn't, it'll roll it back. So some of that automation is already there with Flagger, at least for blue-green deployments, Canary deployments, etc.
Right.
But I think that there's scope, because we now have agents, software and human agent on the same level. They can both make pull requests and make commits to the Git repository. We can see some small opportunities grow for kind of future smarter automation, right? Right now, we're just encoding good practice in a tool and it's just traditional automation. But I can definitely see a software that looks at a set of configuration repositories and says, here's a suggestion, right? I think if you change those requests and limit, then your cluster will work better. I think if you set up those priority classes for your various containers, then or for your various pods, then that's going to be more efficient use of your resources. I believe you can remove a node here. I believe you need to add a node here. All of those things, I think we're going to start to see. We're already seeing, and I think GitHub, the company, has been driving some of this. We're already seeing some really interesting stuff around security pull requests. So software making pull requests to update your version of an insecure dependency. And I think that kind of model will grow over time. And we're seeing the growth there. I don't think the growth has gone exponential yet, but it will do at some point in the future, and that's going to be quite exciting.
Yeah, that's definitely super early days. In fact, I'm glad you mentioned that because just this week I was looking at Sneak, and it has an option that in the interface that says, would you like me to automatically merge these PRs for your security updates and your app dependencies? Because it's already sending me weekly emails about all my stuff saying, here's all the things here's your work for the week. Go check and test and do all these things. And a lot of it in my case is sample code. I'm, for training and workshops and online courses, I provide a lot of sample tools and sample code. And every once in a while, a student will say, hey, this one's got a bunch of security vulnerabilities. You should totally update it. And I look back and I realize I was ignoring the GitHub emails and the Sneak emails. And now Sneak is saying, I'm not just going to do PRs for you, but if you just do this, I will automatically merge it to your whatever branch you want me to merge it into. And I haven't clicked it, but I know that that is better than the alternative, which is waiting on the human to slowly get around to actually updating that stuff. I mean, maybe in some cases, since it's not doing true testing in the background, it's not like it's going and doing full CI to validate that change won't break anything. But the chances are that, preventing the security vulnerability is probably better than the likelihood of it breaking in my sample apps, right? Maybe for real production stuff. Go ahead.
I could definitely see the way where, instead of making a commit straight into your master branch and changing the code, it would actually make a PR that would trigger your CI pipeline to double check everything is working as expected. And only if it's green, then it would go, okay, I've made my change. It's all green. Let me merged that. So now you literally have a software developer, right? That's kind of making security improvements to your software over time. So that's something that's within our grasp right now.
Yeah.
And I think in the future, and this is not even, I mean, this isn't even AI really, right?
No.
This is just good automation with good interface, right? We've started breaking responsibilities up into modules and concerns up, and that enables certain use cases. So I think that's quite exciting. I'm looking forward to kind of automating myself out of a job in like 5 to 10 years time. I think that should be all about, like, that should be a deep-seated desire for all of us to automate ourselves out of our jobs.
Absolutely. There is this thing for forever, especially with Linux sysadmins. One of the first slides they'll put up is, I do all of this because I'm lazy and I don't want to do it again.
Yeah.
And that was essentially early automation. We were writing scripts. Now we're having basically, this is all APIs talking to APIs, and we're just watching it all happen. And we say we want to automate ourselves out of a job, but really we have to continually be on top of that automation, or we will truly be automated out of a job, like so many people are in the modern day and age, where we keep finding ways for robots to do the human things. By the way, the thing that we were thinking about, just put it in the chat, was a CD Foundation. Someone in chat figured it out, as well as Ray, and that was the thing I was thinking of. It was announced earlier this year. It's probably the thing that is related to the working group in the CNCF. It is a Linux Foundation project, and it lists some stuff in there. But yeah, I think largely these are all the same goals, right? That we agree on the things that are unopinionated and that really need to be the foundation for how all these tools work together. But then we all diverge when it comes to opinions and workflows on how we think things should be done, right? So.
Yeah, I think this is what I've found as working as consultant is most of the time it's the politics that you need to sort out rather than the technical side, and that's very true for all this stuff, right? I think the technical side is pretty straightforward around the automation. It's there's no rocket science in here. There's no fancy algorithm. It's all very straightforward. Here's an event. This is what you do after the event. So getting the politics of it and getting that right for both the community, so that's like I would call it the macro scale politics, and the micro scale politics of within an organization, those actually tend to be the harder problems for me that I encounter on a day-to-day basis. It's almost never the technical problems, right?
Right.
We are good. Like, we've gotten to a point where we know how to solve technical problems quite well. We have really smart people in the industry, really smart people working in those companies. So the technical problems can just disappear very fast. But the human problems, the politics problem, the process problems, those are the ones I actually encountered that are difficult to solve. So like the automation out of a job is so I can concentrate on those kind of problems, which are about change management and people management and not software management. I think that's where I see it going, if that makes sense.
Yeah. All right. So we're hitting over an hour on the show. We've got I think we've got all the questions out of the way. Actually, wait, maybe one. Super technical question here. Can we Helm install Flux on an existing case cluster and task it with future updates?
Yes. The short answer is yes. The longer answer is this requires a bunch of random configuration stuff, but the short answer is yes, you can do that.
Yeah.
So you can install Flux with Helm if you want, and then as soon as that's up and running, you can configure Flux to point to the right repository, and Flux will start taking over. There are kind of, I would say, more advanced patterns when you have multi-tenancy and you want every tenant to have their own repository, and you want to create clusters with pre-provision with Flux in each namespace and stuff like that. So there's a bunch of enterprise use cases, but fundamentally, yes, you can install with Helm, and yes, you can then have Flux take over for the deployment.
Yeah, cool. So this whole time, we've been talking about GitOps, which isn't Kubernetes specific, but at least with the tools that we're talking about today, mostly, those tools are Kubernetes specific. So I don't want you to think that GitOps is only possible if you decide to go with Kubernetes, because obviously not everybody needs an orchestrator yet. Not everybody's choosing Kubernetes yet. So if they're just trying to do GitOps in general, and they haven't yet decided on tools, and we're talking about more the human processes and the getting started stuff, I was trying to think like what are the 2 or 3 things we can send people away with. I feel like at least one of them is you probably should have everything related to your servers in either YAML or TOML or JSON or whatever those descriptors are, right?
Yeah, so start declaring stuff and start driving your automation from those declarations. That's the first thing. And we have some really good tools to do that right now that are very broadly applicable. So the HashiCorp configuration language and Terraform, so HCL Terraform, already meets those requirements of being declarative, of being human readable, of being applicable. What's missing for those is just the final control loop at the bottom, number 4. But you can start committing those to Git, all of that. You can already do that with a lot of cloud providers too. So AWS Cloud Formations. They're not necessarily the kind of the most user-friendly interface, but they have those features of being declarative. And what we haven't got yet on those either is the continuous drift correction. We have drift detection, just not drift correction.
Yeah.
But I would say like a concrete example is we manage our GitHub permissions for our organization, and I was doing some of this stuff today. We manage those through Terraform, right? We manage every repository we create is in Terraform. It is defined in Terraform. Write protection on the branches is defined in Terraform. Membership to organization, collaborators, all of that stuff is defined in Terraform for us, which means that we now have kind of a really strong pipeline and really strong governance of our access control for those things, which is quite nice, right? It's a nice feature, and it's using GitOps in a place where it's not Kubernetes at all, right? We're literally driving GitHub, the GitHub API through Ops.
Yeah. I guess if you're exclusive to GitHub and you're using all the new things, all the new features they have, like branch permissions and the new automation actions, maybe you need to those people need to label it as GitHub Ops. So
GitHub Ops,
because they're definitely part of the wave of leading that effort on an automation based out of a Git application. A Git-based application. So, all right. So the first step is get these things in YAML. It sounds like the next step is have tools that will basically get hooks or look for changes in that Git repo and then respond accordingly to those changes. Whether or not that is a GitOps labeled tool, if you're not in a place with your infrastructure where you can just suddenly do the Flux thing on Kubernetes, or maybe you're not doing all that stuff yet. You're getting your tools to take the changes from that Git repo and make them and basically apply them. It sounds like that's probably the next step. So that and the idea there is humans aren't running the commands to apply the changes, right? Because I think that's kind of like the infrastructure as code. That's what we did. That's what we learned how to do that then. We made changes in YAML. Then I would probably go make the changes on the servers. Like I would run the Terraform. I'd run the Ansible of that YAML. And then if it worked, then I would commit it to the Git repo only at that point. So the Git log maybe reflected changes, but it was only after the fact because I wouldn't want to commit something that was broken. So that to me, those are the behaviors that you've got to go through on your way to GitOps. If you're someone who has no infrastructure as code today and you're not putting stuff in YAML and you're not putting stuff in Git, like simply installing Flux to me is like that's a huge culture shift change that you're going to have to adopt, and maybe the tool will enforce you to do it, right? Maybe the tool is the way to enforce you to adopt all these good practices, and that's not necessarily always a bad thing.
Yeah, and I would make the point that what you really want to be doing too is separating those concerns between creating artifacts and deploying them. I think that's a big step, and it doesn't really matter what your target environment is, but you're going to have start with immutable artifacts, right? Try and bring immutability into your system, because a lot of the time what we find is, people will modify a live system instead of changing from one immutable kind of version or configuration or state to another immutable state.
Right.
And that's where the real trouble comes in, because you cannot determine what state your system's in from the outside anymore. And you don't have predictability about the state of your system. So I would say have a drive towards immutability and separate the concerns of deployment and creation of the immutable artifacts. I guess that's fairly abstract. That's very high level abstract, but they're good kind of principles and guidelines to drive you in the right direction.
Yeah, there's this is one of those things where I hate to say, like, maybe hire a consultant that knows this stuff, because I'm imagining the workflow diagram of this is where you are now as an organization, right? In terms of the people, the process, the tooling, and then on the other end of this, we have all the 4 principles of GitOps implemented, and there's this crazy mesh of decision factors and all that stuff all in the middle. And so I'm imagining that eventually this will become easier, and I might have a course on it someday, who knows, and we'll have a way to teach people from the process overview and the human side of it, and then at the end you'll eventually pick a tool. So yeah, well, thank you.
Any good consultant will always answer, it depends.
That's how I always answer it.
Yeah.
And I've also learned recently that I'm really good at giving you an answer that is the answer I don't know, but I spend 10 minutes telling you how I don't know, and then it sounds like I'm smart. I didn't know that I actually had that skill, but recently it came to me that that's what I was doing. Every time they ask a question, I was answering for like 3 or 4 minutes, but I didn't have any idea what the answer was. So maybe that's why I'm still a consultant. Well, thank you so much for being on the show. Brice, tell us about, where are you on the internet? Like, where can we find you? We see your Twitter handle down there, but the people on the podcast can't read that, so let us know.
So if you want to reach out, I'm on Twitter at Fractal Lambda. That's not Lambada. That's not the dance. It's Lambda, like the Greek letter. So Fractal Lambda. You can reach me on my email for any Weaveworks stuff related at brice@weave.works. We've got quite a funky domain name. So if people want to reach me, that's the way to do it. And everything is probably going to be linked from my Twitter bio anyway, so you can find everything else from there.
Yeah, great. Well, thank you so much for being on the show. I look forward to the next time we have you on the show and talking more about GitOps, because we could, like you guys can see, we could talk about this for hours. And hopefully you learned something. We will be live next week again back here on the show. I don't know who our guest is going to be, so you'll just have to like and subscribe to the channel to figure that out. And we will see you next time on YouTube Live. Thanks.
Thank you so much, Bret. Thank you, everybody.